Hey TJ, how are you today? So let's get started by looking at the first problem. And the first problem here is that suppose the cost of producing n cars is the square root of 8,000 plus 1,000 plus n dollars. This is the amount of dollars. Write a formula for the cost per car of producing n cars. All right. So real quick, we know that we're producing n cars. So let's take a quick snippet of this. And if we're producing n cars, it's pretty straightforward right here that we would have the total cost. So the total cost, and in this case, it's the square root of 8,000 plus 1,000 n, and we divide it by the amount of cars. So this is the number of cars, and that would give me the cost per cars. So that divided by n. So that's part A. Part B now is asking us to find the rate of change per car. So we're going to actually find the first derivative of this expression right here. So to find this derivative, we need to use a quotient rule. So the first thing we realize we're going to have is n squared at the bottom. Then we're going to write the top. So I'm going to write n first. Then we're going to differentiate the top. So to differentiate the top, so the bottom first, then we differentiate the top. So to differentiate the top, we're going to have half, because we recognize this here going to be 8,000 plus 1,000 n all to a half. So that's, we're going to bring the half in front. Then we're going to differentiate inside here. We're going to have 1,000. And that's going to be 8,000 plus 1,000 n, and that's raised to 1 minus a half. So that's a half minus 1. That's going to be negative a half. So that's going to be that piece minus the top. So the top here going to be this expression. So that's going to be 8,000 plus 1,000 n to a half, and then I differentiate the bottom. The bottom was given to be n, so differentiate that, that's going to be 1, so that remains as is. This expression now going to becomes half of 1,000, which is going to be 500, so that's 500 and n, so that's going to be 500 n. Since this is a negative square root, I'm going to bring it down, so this is going to be the square root of 8,000 plus 1,000 n, right? Because I write it back in square root form, bring it down, write it back in square root form. So now I'm working on the top part of this. So let's make that be clear. Minus the square root of 8,000 plus 1,000 n. So with that being the case, if I merge this as a single fraction, this over 1, so I'm going to multiply this right here by the square root of 8,000. Let me use a different color to make sure you're following. As a single fraction, working at the top, 8,000 plus 1,000 n. And I'm going to multiply the top also by 8,000 plus 1,000 n. Multiplying this, I recognize, multiply that by that, I'm going to get 500 n. Multiply these two, I'm going to get minus 8,000 plus minus 1,000 n divided by square root of 8,000 plus 1,000 n. Now, so that's my denominator. Now, working this piece out, I'm going to get negative 500 n minus 8,000 divided by square root of 8,000 plus 1,000 n. Now, the thing with that is that this is just a top piece of what we just worked out right here. So if I divide this by n, let me use a different color to differentiate. Let me use a black. I realize that this piece going to becomes, let me put it right here in this my little window right here, If I divide it by n squared, I'm going to get negative 500 n minus 8,000 divided by n squared times the square root of 8,000 plus 1,000 n. So that is my derivative. That is the derivative of the function that we created right here. So let me just do a quick review to make sure you're following. So firstly, the top piece right here, I'm going to have the n divided by the square root of 8,000 plus 1,000 n. Now I realize that if I'm using the quotient rule, it's going to be n squared. Write the top first, which is n. Then to differentiate the top, because I write this as a half, bring all of this up as a half, I'm simply going to get a half times 1,000, differentiate inside here, subtract 1 from positive a half right there, going to give me negative a half minus 8,000 plus 1,000 n to a half. Once I have this now, this piece here going to be the top piece. So I'm working on this piece right here. So to work with that top piece, half of n times that going to give me 500n multiplied by this. This is negative a half. So I'm going to bring this down to 8,000 plus 1,000n minus, this is now the square root of 8,000 plus 1,000n. Now to measure the single fraction, I recognize that this is have a 1, so I multiply this by the square root of 8,000 plus 1,000n and multiply the top by the same thing. Once I multiply the top by the same thing, I realize the denominator now is square root of 1,000n plus, square root of 8,000 plus 1,000n. The top here, these two are the same. So if they are the same, when I multiply them, I get rid of the square root. Getting rid of the square root will yield negative, because there's a minus sign in front, negative 8,000, negative 1,000n. Now that gives me 500n minus 8,000n, because these two gives me minus 500. So as a result, bring this up here. I'm dividing everything by n squared. So as a result, I'm going to get negative 500n minus 8,000 divided by n squared. And that's the square root of 8,000 plus 1,000n. And so that's my final answer. So that completes number 1. All right, so let's look at number 2 now. For number 2, they said a statistician used data from U.S. Census Bureau to construct the model. So we have ST equal to 21, ln 2t plus 2, where ST is the number of TV subscribers in millions in a year. Obviously right here they said that T is 0 correspond to 1980. So we need 1980, use the model to estimate how many TVs in 2015. So all I need to do is subtract, firstly, figure out the amount of years. And the amount of years right here going to simply be 2015 minus 1980. Now once I subtract that, 2015 minus 180, I'm going to get a total of 35 years. So with that, all I need to do now to get the amount in 2015 is to actually plug it into the model. So that's going to be S35, which is going to be given to be 21 ln 2 times 35 plus 2. So that will give me approximately 10.497 million. Alright, so that's part A. Now part B is simply asking us now, use the model to find the rate of change of the number of subscribers in 2015. So first we need to find the derivative. So the S prime of T simply going to be to differentiate ln. Just a quick recall if you don't remember. If I have y equal to ln f of x, to differentiate ln, y prime going to simply be f prime divided by f of x. So divide by the function by the derivative. So in this case we have 21. So that's going to be 21, right, times the 2t, that's the original function. Derivative of that obviously going to be 2 plus 2. Well, not 2, because if we differentiate it, 2 going to be 0. So this 0 going to be out. So we're going to get 2 goes there. We're going to simply have 21 divided by t. And 21 divided by t, we need to do it in 2015. So plug 35 in. I'm going to have 21 divided by 35. I'm going to get approximately 0.6. Right? So that's 0.6 per million subscribers. And that is my rate of change. That's the derivative of that value. All right, so that's complete number 2. All right, so let's look now at 3A. So 3A is asking us for the total sales of the company in millions. T months from now is given by the formula ST equal to that. What is the total sales in 5 months? So to find the total sales in 5 months, all I simply need to do is plug in 5 in the equation here. So that's going to be S of 5. Make my 5 look different from my S. Going to be equal to 0.03 times 5 cubed plus 0.5 times 5 squared plus 2 times 5 plus 3. So that's going to be given the total sales in 5 years. If I work this out, this is going to give me approximately 29.25. So that's 29.25 million. Now the question is asking us now for find the average rate of change between 4 and 6 months. So what we simply need to do is find S4, because it's not. So this is a little bit important. We're not finding the rate of change. Remember, the rate of change is normally used for the instantaneous rate of change. Now we're finding it between 2 different values. So we're going to use a slope formula instead. So it's going to be S4, and S4 going to be approximately, if I plug in 4 in the original equation, I'm going to get approximately 20.92. And if I do S6, it's going to be approximately 39.48. So the average rate of change going to be simply equal to 39.48 minus 20.92 divided by 6 minus 4. So that's going to give me approximately 9.28, and that's my average rate of change given those 2 intervals. All right, so that's complete 3A and 3B. All right, so to differentiate now the original function, that's what C is asking us for 3C. The original function was given to be, let me just do a quick snippet of this. So the original function was given to be S of t, which is equal to 0.03 t cubed plus 0.5 t squared plus 2t plus 3. So that's our initial function. So S of t prime then going to be equal to, this is going to be equal to the derivative of that, which is going to be, let me just check my notes right here, going to be 0.09 t squared plus, if I differentiate 2 by that, I'm going to get just t, and that's going to be plus 2. So that's going to be my derivative. So what I need to do now to find S of prime of 5 is to plug in 5 in the expression right there. So this is going to be 0.09 times 5 squared plus 5 plus 2. So this is going to be approximately equal to 9.25. If I work that out. Now, the question is asking us to give a verbal interpretation. It can be said many different ways. I'm not sure how your professor wanted, but what I would say, it is the instantaneous rate of change at 5. 5 is when, if you go back to the problem, let's look at it carefully. The problem is asking us, S there going to be the sales. So finding the sales specifically at 5 in 5 months, the instantaneous rate of change in 5 months going to be 9.25. That's representing the instant rate of change. So at exactly 5 months, that's the amount that I'm going to actually be selling. That's actually the verbal interpretation of this particular problem. All right, let's now jump to number 4. And number 4 now, let's do a little quick snippet of that. Number 4 now, we're going to be looking now at the integral. So looking at the integral and then going in reverse. All right, so for number 4, let's see if we can jump into that. So for number 4, they told us that f prime is equal to 2x minus 6. For f prime negative 2 is equal to 6 and f negative 2 is equal to 0. Find f prime and f of x. All right, so firstly, we know that if we're given f double prime and we want to find f prime, all we simply need to do is find the integral of f double prime. So to find f prime, I'm going to find the integral of f double prime with respect to x. So with doing that, this is going to be the integral of 2x minus 6 dx. And since it's an indefinite integral, I must have a constant. So to integrate this, I'm going to have 2x squared divided by 2 minus 6x plus c. By doing that, they told us now the derivative, so this is f prime of x. They told us now that this condition is satisfied. So what I'm going to do, I'm going to plug in to find out what c is for that. And to find c, what I'm going to simply do is I'm going to plug in 6, and that's going to be equal to x squared. So let me simplify before I plug in. So that's f prime x going to be equal to x squared minus 6x plus 6. All right. Now, to plug in that value now, that's going to be 6 equal to 4, because it's negative 2 squared minus 6 times negative 2 plus c, because I plug in negative 2 inside right here. So that's going to be 6 equal to 4. 2 times 6 going to be 12 plus c. So that's going to be c going to be equal to 6 minus 16, so c going to be equal to negative 10. So my f prime of x going to be equal to x squared minus 6x plus minus 10. Okay, so that is my f prime. Now let's find f. So that's the next thing that we need to find. So to find f, I know then that f going to simply be f of x, as we know, going to be the integral of f prime of x with respect to dx. I know that. So f of x then going to be the integral of x squared minus 6x minus 10. And this is an indefinite integral, so I'm going to have some constant c as well. So to find the integral of this, f of x then going to be equal to x cubed divided by 3 minus 6x squared divided by 2 minus 10x plus a constant as well. Simplify, I'm going to get f of x equal to x cubed divided by 3. 2 into that going to be negative 3x squared minus 10x plus c. So that is my derivative. Now they give us another condition. They told us that for f we have that as the condition. So I'm going to plug in 0 equal to this going to be negative 2 cubed divided by 3 minus 3 times negative 2 squared minus 10 times negative 2 plus c. Now I work that out. That's going to give me, double check it on your calculator, going to give me negative 32 divided by 3 plus c, sorry, positive 32 divided by 3 when I work that out. And as a result, c going to be equal to negative 32 divided by 3. So finally, so this here, my f of x, going to be f of x equal to x cubed divided by 3 minus 3x squared minus 10x plus, in this case, it's going to be minus 32 over 3. And that is my f of x. And that completes number 4. All right, so for number 5, it's kind of similar to what we did in number 4. F, and we know that f prime is equal to that. So to find f, again, it's going to be the integral of f prime of x, right? So we're going to have to integrate, because remember, we differentiate this to get f prime, so to get the reverse, we're going to have to integrate. All right, so we need the integral of 3x squared minus 2x. And remember, we're integrating with respect to x, so we have to put a dx. So to integrate that, I'm going to get 3x cubed divided by 3 minus 2x squared divided by 2 plus c. So simplify, I'm going to get x cubed minus x squared plus c. Have this condition here. I'm going to plug in 3 for y, so that's going to be 3 equal to 2 cubed minus 2 squared plus c. This right here going to be 3 equal to what? That's 4. Sorry, that's 8. The 2 cubed is 4. 8 minus 4 plus c. So I'm going to get 3 equal to 4 from that. Going to be 5 plus c. So with that being the situation there, so my bad. 4 from 8 is 4. My bad. I'm a little bit exhausted. Work with me. So that's going to be 3 minus 4 equal to c. So c gonna then be equal to negative 1. C is negative 1. So if c be negative 1 now with my calculation, so then f of x then going to be equal to x cubed minus x squared plus, my bad, minus 1. And this is my expression for f of x. All right, so that's complete f of x. Pretty straightforward. So let me just go over it real quick. So the integral is, remember, we add 1 divided by 3, add 1 divided by 2. So we're going to have that. So this is going to be x cubed minus x squared plus c. So this is going to be, plug in 3 for y, 2 for x. Plug in that, I'm going to get 4 minus 8, which is going to be 4. 4 on the left, c going to be equal to negative 1. So this is going to be my expression for that. All right, so let's look at number 6. So for number 6, they said that a certain function g is shown as this. Again, we need to find g. Which following is the closest to g2? They told us that g0 is equal to 5. So let's see if we can put this into perspective now. So we need firstly g. So g obviously of x going to be the integral of g prime of x. It's an indefinite integral again. So we are integrating, we're going to have a constant being generated. So this is going to be e to x when I integrate it, or the integral, let me write it out first, integral of 2x. When I integrate that with respect to x, I'm going to get e to x plus 2x squared divided by 2 plus c. With that being the case, that's going to be e to x plus 2, sorry, x, 2 divided by 2 is 1, so that's x squared plus c. Now, they told us now that g0 is equal to 5, so I can figure out what c is, because this is now my g of x. So to figure out what c is, what I'm going to do, I'm going to plug in 0. And if I plug in 0 right here, I'm going to get e to 0 for x plus 0 squared plus c, and that's going to be equal to 5. Now that is equal to 5, e to 0 is 1, so this is going to be 5 equal to 1 plus c, so c then going to be equal to 4. So if c is equal to 4, my expression then going to be e to x plus x squared plus 4. So that is my g of x. So if that's my g of x now, I need to find which value is the closest to g of 2. So g of 2 simply going to simply be equal to, we have x squared. So with x squared, e to the x, we have, that's going to be e to 2 plus 2 squared plus 4. And then we work that out, put that in the calculator. So you're going to have, let me work it out for you. So that's going to be e squared. So that's e squared plus 4, right? Because that's going to be 2 squared. So that's plus 4 plus 4. It's going to be approximately equal to 15.389. So which value is the closest to this? Obviously, this value going to be E. E is the closest to it. I'm having 15.389. So that's going to be the closest value to my answer right there. So that completes number 6. Okay, let's do now number 7. So for number 7 now, let me check my notes. They want us so this right here, we realize is the antiderivative of that. So the antiderivative of this is going to be f of x, simply going to be equal to, if that's be an antiderivative of this, the antiderivative going to be x cubed over 3 minus x squared plus c. I know that. Now, c is a constant right here, so I need to figure out how much this function is growing over the interval. Now, this constant going to remain fixed, so more than likely that's my starting point. I need to figure out how much it's growing. So at this point, I know that this is going to be a fixed point. So this is not so much of significance at this point. So what I'm going to do, I'm going to focus on that in terms of how much the function is growing. At 0, because it's over the closed interval, I know that the function f of 0 here going to be also 0. And then I know that f of 6 at 6 going to simply be 6 cubed divided by 3 minus 6 squared. Now if I work that out real quick, I'm going to have 6 cubed, which divided by 3 minus 6 squared, that's going to give me 36. So the function I say is growing 36 units right here. So it's going to be 36 plus whatever this constant is. So the constant doesn't really affect the antiderivative. It doesn't really matters because we realize that c here going to be the constant point, and that's where the function is growing from. All right, so that's number 7. That completes number 7. All right, number 8 is pretty much the same thing as before. Let's see if we can run through it. All right, so we know we need f of 2 is equal to that. We need to find f of 1. So firstly, we need to figure out what f of x is. So again, f of x we know going to be the integral of f of prime x by dx. So that's going to be the integral of 3x minus 2 dx. To integrate that, I'm going to get 3x squared divided by 2 minus 2x plus c for my integral. Now, if that is my integral, now what I need to figure out now, I'm given that f of 2 is equal to 5. So f of 2 is equal to 5. I'm going to have 5 equal to 3 times 2 squared divided by 2 minus 2 times 2 plus c to figure out what c is. With my calculation now, this is going to be 2 into this. Going to get rid of rid of that. So I'm going to have 6 right there. So this is going to be 5 equal to, this is 6. This is minus 4 plus c. With that being the situation, 4 from 6 going to be 2, 5 plus c. Then c obviously going to be equal to 3. So f of x then going to simply be equal to x squared 3 times x squared divided by 2 minus 2x plus c. And we know that c here is 3. So that's the situation now. Now we need to figure out what f1 is. For f1, we're going to simply have f1, plug in 1 onto this expression. We're going to have 3 over 2 minus 2 plus 3. This plus that going to give me 4.5 minus 2. This is going to be 2.5. 2.5 going to be 5 over 2. So my answer then going to be 5 over 2. And that completes all of these problems. If you have any questions, please email me ASAP.